Hi, this is Sung, and I'm the principal and the director of Sky Academy. And we've been looking at functions and relations, and we've been mainly looking at the different types of definitions, the notations, odd and even functions. We've been looking at little bits and pieces, but now what I'm going to do is look at the main types of functions that we'll be looking at in this course. Not limited to, but some ones that are very common. Okay, so let's have a look. So I've put them into general forms. So you got quadratic functions, which are parabolas, and we're looking specifically at that. Cubics you might see from time to time. Circles, which we'll be going through in a little bit more detail, so if you don't get it here, then don't worry. Hyperbolas, again, we'll be looking at that in a little bit more detail. Exponential functions, which a whole chapter will be devoted on that. Exponential and logarithmic functions. And then the other one is the straight line, and a whole chapter will be devoted on that too. So let's have a look at quadratics first of all, and let's see what they basically look like. All right. So you got a quadratic is basically recognizable because it takes the form y equals to ax squared plus bx plus c in its general form. X squared is the highest power of x. Y is to the power of 1, okay? And a parabola will either look like that, which is concave up, it's a smiley face, or like that, concave down, it's a frowny face, okay? We'll look more specifically at parabolas in a future chapter, but for now, that's basically what a quadratic looks like. Next, you have cubics. Now you might not necessarily have to recognize a cubic of this form or be able to graph it, but what you will know is that a cubic is a cubic because the highest power of x is 3, right? It's cubed, x is cubed. And for a cubic, sometimes the function looks like this, or it can go the other way as well, right? But when it's of this form, what will happen to the cubic is it'll dip up and then dip down and go like that. Okay? So that's a cubic. Okay? Next, we have a circle. And the way you recognize what a circle is, the highest power of x is 2 and the highest power of y is also 2. Right? X squared plus y squared equals to r squared. That circle there will have a center of 0, 0. But if you want to have a displaced center, a center where the center is at h and k, this is what your function will look like. With r, well, it's not a function, it's a relation, but that's what your relation will look like when r would be your radius. All right? So a circle looks like that. Okay? All right. Next, you have your hyperbolas. And hyperbolas take on the form y equals to a number, which is k, or a constant, which is k, over x. Okay? Or another way to write it is x times y equals to k. And we'll look at hyperbolas in a little bit more detail, but hyperbolas basically look like that. Right? And if k is negative, then it'll be in the other two quadrants. What you will notice about a hyperbola is that it tends off towards infinity, positive infinity, and keeps on going. And then on the other end, it tends off towards negative infinity and keeps on going towards negative infinity. And at the point where x equals to 0, the value of x is undefined. There is no value at x equals to 0 for y. And likewise, the same is true for the x value. There is no defined x value for y is equal to 0. The x-axis and the y-axis in this case are what we call asymptotes. Asymptotes. And I'll introduce you to the language of that asymptote. And an asymptote simply is a line that a curve will get closer and closer to, but will never actually touch. It gets closer and closer to it, but never actually touch. Okay? So that's basically what an asymptote is, and a hyperbola will have both a horizontal asymptote and a vertical asymptote. Now let's move on to exponential functions. Exponential functions take on the form y equals to a number, a, or a constant a, to the power of x, or to a power of some function of x. And in its positive form, where x is a positive, where x has a positive constant in front of it, it will look like this. Right? The x value, as it gets increasingly big, will veer off into infinity for y, and as x gets really, really negative or smaller in the negative direction, the y will veer off towards some finite value, in this case 0. And so what does that say about the x-axis? Yes, you guessed it, it is what we learnt here, it's an asymptote. Okay? So an exponential function looks pretty much like this. It starts off flat and then gets really, really, really steep. And finally, you will recognize this as straight line, and we will devote a whole chapter to the straight line. Y is equal to ax plus b, and that looks like that, or it can also look like that.